All right, here we go. You know, doesn't have to be whatever. So, now, will the camera focus? Okay, I am going to make sure this is plumb and straight from two directions. That looks good. That looks good. Look from the side. It looks pretty good from the side. I think it's, let's go a little that way. I don't know. Hand doing it. Check it for square. Not terrible. Dude, this thing is really square, checking it with the edge of a parallel. I'm going to put this on top. All right. Crank. Okay, I'm going in with 1 ton. And its bottom. I just put this piece of aluminum on top. All right, fair enough. Yeah, that went in with 1 ton. Look at that. It's a win right there. See, it went up to only 1 ton, which is the first tick mark. So, yeah. Man, that's great. So now I can use a 5/8 collet instead of that chuck. Take it down to size, baby. Oh yeah. Because this, I got a whole bunch of these discs. It'd be different if I had a long piece of stock and I could do the features and then part it off, but I don't, so. All right, let's go set up a collet. Boing. All right, guys, we got that set up in a 5/8 collet, and this actually measures 3 1/8, and I got to go to 2 1/8, so I got to take off basically 1 inch, and we'll sneak up on it once we get close. But the face is within 1/2 thou, so that's perfect. Let's see what we can do here. See what she'll cut. I'm gonna try, I think, 50 thou, maybe. So let's go to 100. All right, let's power feed. That's a lot of stringy ass chips. Whoa. It's leaving really blue chips, like black. That's going fast for the surface feet per minute. I'm telling you, this must be 1050 steel. At least it's not making stringers anymore. What's nice is you can tune this lathe in because everything's variable. Go another 50, because you know, let me speed up the feed just a little bit. No, it's making them curlies again. No. See, these curlies are not what you want because they're a pain to clean up. See, now it's like a variable hardness. It's kind of weird. See how that changes? Different variations in the steel, it must be. I don't understand that. And there it goes stringy again. Let me do something. There's another 50. It's gonna be a pain to clean up. That's better. Well, I had to say something, and then it... Let me really hog it. There you go. I was under the chip breaking number, and I wanted to be over the chip breaking number. If you know what that means, it's sort of hard to explain. Chips will break if you're going too slow. If you're right on the speed and feed, it'll curly Q, and it'll also break if you're going above that magic number combination. There's another 50, and it changes when this thing gets smaller, right? Here we go, 50. Yeah, it's making nice little 9s and 6s. Another 50. Once you dial it in, nice. And the chips are not turning color even. They're just starting to turn the lightest yellow. I don't want to push it any harder than this because I'm on a 5/8 post, right? But the ability to tune the chips is nice. let's shake the camera. You can see the swarf I'm getting. So I'm at 150, this diameter, it's 200, and the power feed lever is here. Ready? Go. Another 50. $51, who cares? Power feed, lever, engage. Stop, bring it back, go to 100, sorry, and where is she? Check our size to make sure we don't blow the world up here with our missing our dimension. Alright, so that's fun. I'm going to keep doing this until I'm down to my number, and I won't make you watch the whole thing. Alright guys, I am 50 thousandths to hit my size, and it's hot. Yow, freak nuts, it's hot. I'm going to let it cool, because it'll change a couple thou in the process of cooling down. And I'm not going to take 50 thou a whack anymore. I might take 10, 10, and tune it in to an even increment. And then I'll take it out, and what I'll do is I skimmed the bore. Back up. The mighty Colchester 17. I got the 1.5 inch boring bar, and I went in a little bit further than I needed to, but this is a real tight 2 1/8. So I can take it out of the collet because it's on the dowel pin and fit it. And then the next step is I want to put it like 4 or 6, probably 4 would work, holes. I want to index, put 1/4 20 set screws, not set screws, 1/4 20 Allen head, maybe button head screws to retain this in there. So I need to index this in some kind of indexing device. I've got a few indexers. I want to do this with, you know, the easy way. I don't want to go crazy with the indexing. I got 2 Harding indexers, which are the smallest ones I have. I can put a chuck on them and then clamp this in the vise as a tailstock, and just, we'll see. We'll get into that. All right, I'm going to take a break, let that cool off before I do my final numbers, and we'll bring you back. All right, we've got that hockey puck bored to a 1/2 thousandth to 1,000th press fit. This is a 1/2 thou oversize from 2 1/8, and the bore is a 1/2 thou undersize from 2 1/8, and it just it'll barely start in there. So The reason I wanted it a little bit of a press fit is so I can push this flush, you know, push it home, push it flush, and then it'll stay in there flush while I put the 4 screws in, while I drill and locate the 4 screws. So now I'll push this mandrel out with the press, and I'll chuck this in the 4-jaw, and then I'll bore the center out. And I found a bronze bushing for that 7/8 shaft there on the end of the Acme. So, all right, we'll bring it back. All right, I got this all set up in the press. We got the bolsters here, and there's a V-block hole in the middle. This thing with the holes, that's just a hardened piece of a die set. There's the piece, of course, and I got just a hardened pusher. So let me put the pressure to it, and let me roll this hand levers. All right, so it stops there. Now the hydraulics, I'll start pumping the hydraulics. And it is moving. You can see on the gauge, what are we at? 1 3/4. 2 is the middle, so almost 2. And I guess I'll let the pin fall on the floor. There it goes. And release this and line this back up. Okay. And the pin's on the floor. We'll pick that up in a second. Take that. Put it back. That's done. Set that there. Put this back. Down on the tooling shelf. And here we go. You just get that pin. All right. There it was. Took a little. Nothing. It's like wasn't even there. So that's a way that you can oops. That you can fixture your parts. See, I leave a witness line with that magic marker so I could install it back in the collet if I had to take a few more thousandths off. But this is good. I'm going to chuck this in the 4-jaw, center it up on the outside, and bore the middle. Found this bushing, right? And it I'm not going to do it, but it does go on. There you go. That's a tight fit. So I think I've got a 7/8 reamer to run through that. That's a centered oilite bushing. So it'll have the thrust bearing to take up the axial load, and then the radial loads will be taken up by the bushing. So let's get this centered in the 4-jaw, bore it out for a press fit. I think that's 1 inch on the outside, and we'll get that fixtured and bored out. So here we go. One thing I wanted to stop and focus on, being the operative word here at this silly camera, is if you look at this hole, inside, it's a mirror finish. Looks like a mirror. It looks like highly polished chrome inside the bore, not the surface of the end. But if I flip it over, you'll see there's a ring on top. Okay? And what that ring is, That's the chamfer on the dowel pin. That's where the chamfer was. Okay? And I know it's the reflection's terrible. But it goes from a mirror-like finish to that turn finish, and that's where the dowel pin was not touching. It was only touching where the press fit was. And because the chamfer, as I said, on the dowel pin was at the top, it didn't touch there. So wherever the dowel pin was press fitted into this bore, it got polished like chrome. Now, can you feel that as a step or a transition? I cannot. A profilometer that measures surface finish could. But what I'm trying to get at is when you push that dowel pin in there and do the press fit, that's burnishing. That burnishes the bore. And what is burnishing? Well, plainly put, burnishing in regards to the surface finish, it knocks the peaks into the valleys, right? On a microscopic level, the surface finish is very rough, you know, under magnification. And that by burnishing, whether using a hardened dowel pin or they use a ball, a hardened steel ball to burnish, they use different things. Cogsil is a company that makes roller burnishers. They look almost like Timken bearings that roll on the surface and burnish it. But that's what that is it's knocking the peaks of your surface finish down into the valleys, and it's actually making the bore bigger, or in case of the outside surface, you know, you can roller burnish an outside surface, it makes it smaller. So when you have a dimension, a size dimension, size is absolutely related to surface finish. 100%. Size with a rough surface finish, that means you're measuring to the peaks, and it's not a very, I guess robust is the only word, that durable, not a durable surface, because in use, whatever the application is, you can knock the peaks off and the size gets smaller, right? Whereas if you had a given dimension with a very fine surface finish, a polished surface finish, there's not a lot of peaks and there's not a lot of valleys. It's more of an even surface. So that's a more durable surface because there's no peaks to knock off. So that's what burnishing does. It knocks the peaks into the valleys and creates a flatter surface. Not flat over a great area, but flat locally. But I just wanted to show you that, what burnishing does and what a press fit burnishes a surface. So if I measure that after having press fitted that pin and pressing it out and now it's burnished, that'll measure maybe a tenth larger because you're not measuring the tops of the peaks anymore. The peaks are gone. So the bore is actually going to measure bigger. If you had turned or ground or lapped that surface to a finer finish, if you did a press fit and popped the pin back out, that surface would probably be the same diameter. You couldn't even measure it because the peaks are already gone. You're not relying on the press for the pin to knock the peaks off. So size and surface finish are very much interrelated. And a lot of engineers and mechanics and machinists, they don't really think about that too often. But I just wanted to talk about that because we had a burnished condition from the pin being pressed in and pressed out. So something to think about. All right, guys, showing you, this is the kind of run out you need to try and achieve with precision work. Can you see that needle bobbing around? This is a tense indicator. Thing's hardly moving. And if you don't believe me, this is the face run out, the axial run out. I'm going to take this, I got it on a piece of paper with a magnet. thing's got nothing, right? So what I'm going to do is move the magnet back, change my orientation. I'm going to probe the bore. The thing's hovering right around 1. It's just hovering. No, that's shanked out. Come on, baby. Well, I mean, it's running in the bore. Let me shut it off. But that's the kind of run out you need to tweak in, you know, to get it right. And I had the bore good, and I had a half thou on the face run out. So I just took a chisel and I just gave it the lightest tap. Took that, I could have tapped it in on the other side, but it doesn't matter. And I got a little space behind there so I don't hit the chuck with my there you go. So I don't hit the chuck with my boring bar. But that's, like I said, that's a tenths indicator. 0 to 4 and back to 0, so 8 thou total. But now I know I'm going to be still centered up and I can bore this. I think it's the 1 inch with that bushing. But I'm all set up to go. Thought I'd show you that, just how to, you know, these little 4 jaws, man. I mean, you know, they're great. I've got so many. All right. Got that 4 jaw. That's a 4 jaw. This is an Elgin. Yeah, that's an Elgin 4 jaw. If you know Harding, you know Elgin. It says right on it. And there's a Skinner grinder chuck. I got like 2 others of these. It's called a grinder chuck because they're not open to a scroll in the middle. This intersection here, you cannot see the scroll. It's all sealed from dust. And because that is closed up in the center, it doesn't have as much adjustment range, so they put a couple extra steps in these top jaws. And well, I got a key for it somewhere. But lots of 4 jaws. Got some dogs for the Brown & Sharp 13. Lots of chucks. And this shelf is paying dividends. It's being really handy for just doing my lathe work. It's like 11 o'clock at night. I'm tired. I might go in and watch some internet and go to bed. But I got about 3 of these little 5-inch Harding chucks. They're not made by Harding. I think I don't know who they're made by, Pratt Bernard or somebody. But I love indicating, man, and when I can get something, you know, with perfect axial run out and perfect radial run out. I say perfect, I mean within a couple tenths. Alright, I love coming out in the shop at night. For some reason I feel like it's bonus hours because it's dark out for some reason. But I'm going to do this tomorrow morning. I just wanted to show you my setup and bring you along with the ride of this thing. Yeah, hot tip, you don't want to scratch your bed up. Put a piece of paper under your magnet. And it makes it easier to move around. So, all right, we'll bring you more in a little bit.